Greetings, salutations, all those nice things, and welcome to this video lesson on relating trigonometric ratios. There are some things we know how to do so far. We know how to find a reference angle. We know how to define sine, cosine, and tangent based on a point xy in the Cartesian plane. And we're going to be putting some of those things together to develop new rules so that we can find sine, cosine, tangent of angles that go beyond that 0 to 90 range that we played with last year. Where last year we played with only acute angles, we're going beyond that in the 0 to 360 range. For a little warm-up, try these first two examples. This is something that we do have the capacity to do already. But determine all the angles theta between 0 and 360 degrees in this particular angle family. So reference angle is 30 degrees. What could that be in each quadrant? And same with the next one, reference angle of 55 degrees. What does that become in each quadrant? I'll pause for what I think is an appropriate amount of time. You don't have to pause the video. I'm just doing it. And I'm back. So a reference angle of 30 degrees, we are basically looking for how far from an x-axis angle that would be. Right? So we're always 30 degrees away from an x-axis, which would be 0, 180, or 360. So all of the possible angles would be being 30 away from 0, which could be positive or negative 30, but 0 is our low bar. So 30 degrees. We could be 30 degrees away from 180 degrees. So 150 is 30 away from 180, but so is 210. And then finally being 30 away from 360. 390 is an option, but that's a little too high here. So the only one that fits is 330. Please note the notation here. We've got theta is an element of this whole set. It is acceptable to write instead something like theta is equal to, and then just write the list with commas separating, no curly braces. So like this is okay, but if you put curly braces on here, this is not okay. Now you're saying theta is equal to a whole set. That's not true. Theta is just one of those things at a time. Just be careful with notation. Anyways, in the next example, angle is beta, and beta is 55 degrees away from an x-axis. So that tells us that it could be straight up 55 degrees, that's 55 away from 0. We could be 55 away from 180, so that would be 125 or 235. And we could also be 55 away from 360, which brings us to 305 degrees. What is interesting about angles that are part of the same angle family is that their trig ratios will almost look exactly the same. They will have the same magnitude. And what will differ, potentially, is whether they are positive or negative. And to determine whether they are positive or negative, we have something called the cast rule. It is developed as follows, and this is expected to know to be able to repeat or prove. So this is where the cast rule comes from. First of all, we know we have our axes y and x, and whenever we have some point in there, don't draw this dot, but like there, remember that we could define ourselves as having a right triangle based on that. Define x, y, and r. We have definitions of sine theta, cos theta, and tan theta. But that's not what we're drawing in here. In this quadrant, this is quadrant 1. That I is a Roman numeral. In quadrant 1, we know that we've gone to the right and we've gone up. To get anywhere in quadrant 1, that's how we have to go there. If you're going right, that means that x is positive. And if we're going up, that means y is also positive. And then there's r. Remember that r is a length. It's the distance to the point. R is never negative. R is positive. Well, if that's all true, then we can look at some ratios. If we look at x over r, that's a positive number divided by a positive number, which gives us something positive. But x over r is the definition of cosine of theta. So this means that cosine of theta is positive. We can also check out y over r. And since both y and r are positive, their quotient, y divided by r, is also positive. Y over r we know to be sine theta. And then the last ratio we'll look at is y over x. Again, both of those are positive, so their quotient is also positive. But we know y over x to be the definition of tan theta. So this means that tan theta is positive. A conclusion we draw from that is that in quadrant 1, all of the trig ratios will be positive. Whoopsie daisies. And I wrote that A nice and big for who knows what reason. But this little feature here will come into play. We're going to do the same thing with the other 3 quadrants. So looking over to the left at quadrant 2. In this quadrant, to get anywhere in here, we have to go left and then we have to go up. That's how we get there. If we go left, that means that x is negative. If we go up, well, y is positive. And then r is always, always, always positive. This tells us stuff. If we look at x over r is a negative number divided by a positive number. So that's negative. And that means that cosine of theta is negative. If we look at y over r, those are both positive right here, so their quotient is positive. And that means that sine of theta is positive. We look at y over x, and that's a positive divided by a negative. That's overall giving us a negative. So in quadrant 2, tan theta is negative. And if we look at this, cosine is going to be negative, tan is going to be negative, but sine and only sine is positive. So we can state in quadrant 2, only the sine ratio is positive. I'll give those fancy underlines. It's beautiful. Take a moment. Try the other 2 quadrants. This time I will actually ask you to pause the video real quick. Pause it for, I don't know, 3 minutes? That should be sufficient. Well, hopefully you paused it because I'm back. And we're looking at quadrant 3. in quadrant 3, to get anywhere in there, we have to go left and then we have to go down. Because we have to go left, we know that x is negative. Because we go down, we know that y is negative. And r, what's r going to be? That's not a trick question. It's just something every single time it's always positive. Don't forget that. It's a length. Because of this, when we look at the ratio x over r, we're going to get a negative divided by a positive. So that is negative, meaning that cosine is negative. When we look at y over r, we're going to take a negative divided by a positive, so that's also negative. So the sine ratio is also negative. But when we look at y over x, that's negative divided by negative. That is positive. So in this quadrant, the tan ratio is positive, and it's the only one that's positive. Sine and cosine are both negative. So the statement we write is that in quadrant 3, only the tangent ratio is positive. And look at some fancy dance underlines. Can't forget those. Super critical. Not really, but they could be. And then quadrant 4, which you also did during that short little break. It's over here. And in quadrant 4, we've gone right and we've gone down. That's how you get somewhere in quadrant 4. We go right, so x is positive. We go down, so y is negative. And then r, as always, is positive. We look at x over r, that's positive divided by positive. That is positive. So cosine must be positive. We look at y over r, that's negative divided by positive. That's negative. Therefore, sine theta is negative. And then there's y over x, that old chestnut. And we've got negative divided by positive gets us an overall negative. So tan theta is negative. In this quadrant, sine and tan are negative, but cosine is positive. Our concluding statement is that in quadrant 4, only the cosine ratio is positive. Boop. 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 You look at what's positive in each one of these quadrants. In quadrant 1, it's all of them. In quadrant 2, it's just sine. In quadrant 3, it's just tan. And in quadrant 4, it's just cosine. And that is your cast rule. It tells you which trig ratio is positive in each quadrant. The C for cosine, the A for all of them, the S for sine, and the T for tangent. And I'll tell you, when I wrote all of my trig tests and quizzes when I was in high school, there were a couple of things I wrote on every single one of those. Right before I did any of the questions, I would write the two special triangles, and I would put down this. And that would tell me where each of these trig ratios was positive. So we're going to put this to use in a question like this. Again, these are all part of the same angle family. We found that earlier. 30 degrees, 150, 210, 330. They're all part of a 30-degree angle family. They all have the same reference angle. And because of that, when we look at sine theta for any of these, they're all going to have the same magnitude. And what might differ is the sign, like whether it's positive or negative. So if we're talking about a 30-degree angle and we want sine theta, for that, I'm going to use special triangle. And it's that special triangle with the 30-degree angle and the 60-degree angle. There it is in all its glory. And when we look at sine of 30 degrees, there's 30 degrees. Opposite over hypotenuse is 1 over 2. So this is 1 over 2. For the other three angles, they will also have a magnitude of 1 over 2. And we just need to figure out whether they are positive or negative. For that, we use the cast rule. C, an A, an S, a T. So an angle of 150 degrees, and that's over in quadrant 2. And in quadrant 2, sine is positive. So this 1/2, it stays as 1/2. It's already positive, that's all good. 210 degrees, that's in quadrant 3. And in quadrant 3, only the tan ratio is positive, which means sine must be negative. So this can't be just a regular 1 over 2. It's got to be a negative 1 over 2. Looking at 330 degrees, that's over in quadrant 4. In quadrant 4, only cosine is positive, so the sine function is negative. So this can't be positive 1 over 2. It has to be negative 1 over 2. So again, they all have that same magnitude, but 2 of them are negative, and it just depends which quadrant we're dealing with. It's that kind of approach we can use for questions like this. This should look like, however you spell like, nailed it. It looks like the sine of whatever the reference angle is. This reference angle is probably 60 degrees. It's 60 away from 180. So it's going to look like sine of 60 degrees. So for starters, I'm going to say, okay, sine of 60 degrees, that's adjacent, oh wait, there it is. There's 60 degrees. Opposite over hypotenuse is root 3 over 2. I'm just going to write down root 3 over 2. But is it positive? Is it negative? These are the mysteries. So using some cast rule, I'll note we're talking about 120, which is in quadrant 2. So it's positive. This one's done. Huzzah! And we can be happy about it. This next one, angle of 240, how far is it away from an x-axis? 60 degrees off. So this should also look like sine of 60 degrees. And sine of 60 degrees is root 3 over 2. But is it positive? Is it negative? Let's check cast rule. 240 degrees is somewhere in quadrant 3. In quadrant 3, tan is positive, so sine is negative. We have to throw a negative onto this root 3 over 2. Take a moment. Try the next two examples. Pause for like a minute and go through them. Well, hopefully you paused. And I am. Cos of 315 degrees. It's some distance away from an x-axis rotationally. How far off is it? It's 45 degrees off. So this should look like, if we're taking the cosine of 45 degrees. They'll look pretty much the same. And cos of 45 degrees, oh my goodness, that's going to require a special triangle. Specifically, this one, the 1 root 2, and 45 degrees. Cosine of 45 degrees, adjacent over hypotenuse, is 1 over root 2. So I'll write that in, 1 over root 2. And I'm done. Just kidding, I'm not. I have to check cast rule. And by the cast rule, looks like 315, we're talking about quadrant 4. Cosine's positive. Okay, so I was done. That one is complete. And this other one, tan of 135. 135 is 45 degrees from 180. That's its closest x-axis. So this should look like tan of 45 degrees. Tan of 45 degrees by that special triangle over here, opposite over adjacent is 1. So we put that in there. And then again, checking cast rule. 135 is upper left here. Sine is positive, tan is negative. So this gets a negative sign. Questions, comments, concerns? Just kidding, I can't see your hands. We are going to use these skills to do one other thing, and that's to solve trig equations. When we are solving, we're going to solve over this interval between 0 and 360 degrees. I'm not really going to go outside of that this year. That seems like a next year thing. But this year, 0 to 360, that's the big change from last year. When we do that, first thing we're going to want to figure out is the reference angle. And for the reference angle, we don't care if this is positive or negative. We're just looking at the fact that there's a 1 and a 2. So, by special triangles, which reference angle is going to give us a cosine ratio of 1 over 2? If you need to draw the reference angle or the special triangle for yourself, draw it for yourself. There's nothing wrong with that. Again, I put this on every single test and quiz I wrote in high school. Well, not every single one, but the trigonometry ones. Those are the ones. By this triangle, we can see that if we need to have adjacent over hypotenuse be 1 over 2, then we have to be dealing with this 60-degree angle. That tells us that our reference angle is 60 degrees. But which quadrants are we in? Well, cosine theta is this positive value. So according to the cast rule, we have to either be in quadrant 1, where all things are positive, or quadrant 4, where only cosine is positive. In quadrant 1, we're talking about just being 60 degrees away from 0. So that's that answer. And in quadrant 4, we're 60 degrees away from 360. So that's 300 degrees. Now when it's DUN, done. Looking at next example. Once again, we're going to ignore this negative temporarily. So just for figuring out what we're doing with special triangles, we're just looking at the magnitude of what we've got. We've got a root 3. We know tan is opposite over adjacent. So let's figure out which angle we're dealing with. So that opposite over adjacent is root 3. Again, ignore this negative for now. It's not there. To have opposite over adjacent be root 3, we need to be dealing with 60 degrees. So once again, the reference angle is 60 degrees, but which quadrants are we in? And that's where we stop ignoring that thing we blotted out in pink. Yeah, this tan ratio was negative the whole time. So let's look at cast rule. We're not going to use quadrant 1 because everything's positive there. We need negative. Quadrant 2, only the sine ratio is positive. Nice, we'll use that. Quadrant 3, maybe? No, tan ratio is positive there. And again, we need negative. Quadrant 4, only cosine is positive, tan is negative. So we're dealing with answers in quadrants 2 and 4. That means we can use the quadrant 2 version of 60 degrees. So 180 minus 60 gets us 120 degrees. Sorry. And then quadrant 4, that's 360 minus 60, so 300 degrees. take a moment. Try the other two questions and see what you get. In a moment, just pause the video, try it out for like 2.5, maybe 2:45. 2 minutes and 45 seconds, that is, not 2 hours, 45 minutes. And then resume the video, see if it matches up. Well, and we're back. We're looking at this business where sine theta is -1 over root 2. And again, I'm just going to ignore that negative. It doesn't factor in yet. I just need to know what reference angle I'm dealing with. And if I have a root 2, I must be dealing with this 45-degree right triangle. All right. Well, that tells me reference angle is 45 degrees. And which quadrants? Yeah, that's where we've recognized we're dealing with a negative value the whole time. Sine is negative, not in quadrant 1 or 2, but in quadrants 3 and 4. So, theta itself could be whatever gives us a reference angle of 45 degrees in quadrant 3. That would be 225 degrees. And same in quadrant 4, we're looking at 315 degrees. And then example J. Cos theta is -1 over root 2. I'm ignoring that negative. Get out of here, negative. Cramping my style. So this is also a 45-degree family affair here. So reference angle, 45 degrees. And which quadrants am I in? Cosine is negative. That happens in quadrant 2 and quadrant 3. So my answers here are, I can't do math. Yeah, I can. 135 degrees and 225 degrees. It is worth noting, the more that you play with these angle families this year, the more values like these are going to stick in your head brain. But don't just memorize what the values themselves are. Remember just where they came from. That is per necessary. So that is all the non-calculator stuff of this lesson. There is also calculator stuff in this lesson. Like on this page. Whoop. We're given a case like this. That is not a special triangle scenario. We're not going to get an opposite over hypotenuse of 0.4 from one of the special triangles. So we're going to need to use a calculator for a scenario like this. But core concept is the same. We need to find the reference angle and then determine which quadrants we are in. For the reference angle, that's where this calculator comes in. We're going to ignore whatever sign is in front of it, whether it's positive or negative. Who cares? We're just going to look at this business of 0.4 and use that in our calculators to get the reference angle. So the reference angle is what we get when we take inverse sine of 0.4. And that gets us some value. What are we rounding to? Nearest tenth. I could do that. I could do that all day. So on your calculators, you take the inverse sine of 0.4. And me to one decimal place, I'm getting 23.6 degrees. According to cast rule, I must be in quadrants 1 and 2 because this ratio, 0.4, is positive. Oops, I do want those. So, this beta could be 23.6 degrees. That's in quadrant 1. And in quadrant 2, it has to be 23.6 less than 180. I'm getting 156.4 degrees. In this last one, we're dealing with a negative ratio, but that does not concern us at first. We ignore that at first. We say the reference angle will be found by using the inverse function of just ignoring the sign on that 3.36. So please note that this is positive. For finding the reference angle, that has to be positive. It seems there's always someone every year who doesn't do that. Don't let it be you. In any case, the reference angle, inverse tan of 3.36, is, to one decimal place, 73.4 degrees. Now we can consider whether it's positive or negative. The tan ratio is negative, so we had to be in quadrants 2 and 4. So alpha could be the quadrant 2 version of this. So for 73.4 short of 180. And then we're looking at 106.6 degrees. And in the other one, quadrant 4, we're looking at 286.6 degrees. Oops. There we go. So that is that. And then finally, we can use the cast rule to find some info about a given angle just on whatever information's provided. In this situation, we need to determine cosine and tan of theta. We are told some stuff about theta that's going to help us on our quest. First of all, we're told that tan theta is positive, and we're given that sine theta has an actual straight up ratio given to us, but more than that, it tells us whether sine theta is positive or negative. So I draw this little cast rule business right here. I take into account the fact that tan theta is positive, and that must happen either in quadrant 1 or quadrant 3. And here, sine theta is negative, and that can only happen in quadrant 3 or quadrant 4. That tells me we must be in quadrant 3. It's the only one that meets the criteria, but both of these criteria. From there, we determine the values of cos theta and sine theta. Well, since sine theta is y over r, we can say that we'll let y be negative root 7 and r be 4. We won't let r be negative because r is never negative. Don't forget that. And now we can find whatever that other thing was, x. So x squared is r squared minus y squared. X squared is, what am I doing here? 16 minus 7. X squared is 9, which means x could be 3 or x could be negative 3. But we are dealing with quadrant 3. So the positive option can't be chosen. X has to be negative 3. Therefore, cos theta, which is x over r, is negative 3 over 4. And tan theta, which is y over x, is this negative root 7 divided by this negative 3. So something positive. And that's positive root 7 over 3. Phew! Take a moment. Take 210 seconds. No, that's too many. 150 seconds. And try this last example. I'll keep this on screen. Again, pause it and then resume. Oh, you paused? You resumed? Welcome back. Let's rock this party. We're given info about the signs, whether we're positive or negative. So, by cast rule, since cos theta is less than 0, we must be in quadrants 2 or 3. Tan theta is negative 3 over 4. So tan theta being negative happens in quadrants 2 and 4. Boom diata, we're in quadrant 2. That's a thing we know. Tan theta is y over x. So we got to figure out, like, is y negative? Is x negative? One of them is negative. We're in quadrant 2, though, so we know that. This tells us that x is negative, y is positive. So we will let y be 3 and x be negative 4. That way we get that tan ratio. We ensure we're in quadrant 2. R squared is x squared plus y squared. That's a thing we know. So r squared is 16 plus 9. And r, we don't say positive or negative 3, because remember, r has to be positive. So r is 5. Therefore, sine theta is y over r. So that is 3 over 5. And cos theta is x over r. That's negative 4 over 5. Whew! That was a doozy of a lesson. What would I suggest for practice? I would suggest the workbook. So make sure you do that. It's a lot to take in, and it's going to require a solid amount of practice to really be secure with it. So please, pretty please do that. I mean, really it's for your sake, not mine. But it will make the tests a lot easier to mark if you do it. That'd be great. Please and thank you. Super swell splendid. It's been lovely. I will see you in the future. Be good to yourselves and be good to one another. The